Hello everyone, this is Pardiva Munnaluru. Today's focus is on building a resilient automated monitoring platform for voice over IP systems and how this approach reflects a broader shift in platform engineering. Clear, reliable voice calls matter, whether for business or personal chats. Keeping those systems humming is no small feat, and this presentation shows how it's done. The platform predicts issues before they disrupt calls, streamlining work for developers. Let's start with the big picture. Platform engineering has evolved from reactive maintenance to intelligent predictive operations. Modern infrastructure demands monitoring systems that detect and resolve issues before end users are affected. The resolution presented here, the solution presented here is a centralized platform that emphasizes automation, scalability, and seamless integration with the development workflows. This is not just another dashboard producing endless alerts. It is an intelligent system capable of rapidly identifying genuine issues, minimizing operational burden, and reducing costs. The emphasis on fewer service disruptions and faster innovation. Picture a monitoring system that doesn't just flag problems, it stops them before they start. First, let's explore the challenges this platform tackles. Monitoring distributed system often feels like chaos. Disconnected tools, false alarms, and time consuming manual fixes. So, IP systems introduce complex, heterogeneous environments with fragmented visibility. Traditional monitoring causes alert fatigue due to false positives, while manual remediation slows recovery. The platform was designed to address all these problems simultaneously, providing accuracy, speed, and self optimization. This platform uses machine learning to spot real issues, predict trends, and learn from past patterns, all the while cutting through the noise. How does this happen? It starts with platform engineering principles. A strong platform should feel invisible, meaning reliable, stable, and low maintenance. Platform engineering builds infrastructure that developers love. Monitoring infrastructure must be treated as a product with user experience, reliability, and continuous improvement as core priorities. In real time communications such as voice over IP, there is no tolerance for delays. Reliability must be absolute. The platform handles routine tasks, freeing developers to focus on creating with clear insights when needed. Let's look at architecture that powers this. Imagine a system built for flexibility, speed, and handling any challenge thrown at it. Microservices provide modularity and independent scaling. Apache Kafka forms the backbone, enabling high throughput, fault tolerance telemetry streaming. A plugin-based ingestion layer collects data from diverse voice over IP environment. Prometheus and Elasticstack delivered deeper metrics, logging, and visualization. These tools are selected because they are proven and they're highly scalable and they're open source. The architecture ensures scalability and fault tolerance without redesign. It is like a toolbox for voice over IP monitoring. Works with any setup, no hassle. Let's zoom in on how these pieces come together. Data flows from call quality metrics, network indicators, and system performance, that's what diverse data into real-time pipelines. Machine learning analyzes telemetry continuously. Dashboards, alerts, and automated remediation are produced from this unified flow. This is not just data collection, it is continuous learning and adaptation. This diagram maps the journey from raw voice over IP data to actionable insights. All metrics, network stats flow through Kafka, get processed instantly with fine tuned machine learning models, and appear as dashboards, alerts, or automatic fixes. Developers access these insights right in their tools, APIs, IDE plugins, and so on. Machine learning plays a huge role here. Let's dive into that. Machine learning algorithms establish baseline performance patterns and detect subtle degradations early. False positives are reduced by distinguishing normal variation from real issues. Quality prediction models forecast future performance trends, enabling proactive intervention before users are affected. This represents a shift from reactive monitoring to intelligent prediction. If call quality drops, the system knows if it's a blip or a problem, avoiding pointless alerts. Your false alarms and proactive fixes keep users happy without the chaos. This predicts this predictive power needs a fast processing system. Let's check that out. Using a Lambda architecture, the system combines millisecond level streaming and its alerts with batch analytics for deeper insights. This platform uses a dual approach: instant alerts for urgent issues and deeper analysis for trends. Built-in back pressure mechanism prevent overload during traffic spike. Event correlation identifies root causes, minimizing cascading failures and unnecessary alerts. Features like circuit breakers and event correlation keeps things steady, even during traffic spikes, and pinpoint root causes. Spotting issues is one thing, fixing them automatically is where the magic happens. Issue detection triggers an automated response engine. Validated remediation actions are selected based on severity and historical success. When a glitch appears, the platform doesn't just send an alert, it picks the best fix, checks if it's safe, and applies it. Procedures execute safely with dry runs, Kennedy deployments, and rollback mechanisms. Every action improves future responses. The system continuously learns from outcomes, delivering self healing infrastructure with guardrails. Automation lets teams focus on building rather than firefighting. Developers benefit big time from this setup. Let's see how. Monitoring must enhance, not hinder developer workflows. The platform is designed to make developers' lives easier, not add complexity. An API first design offers programmatic access to the configuration and data. CI/CD integration deploys monitoring upgrades alongside application code. Issues can be caught locally before code ever hits production. Local monitoring and IDE plugins provide real time insights without extra overhead. And it's not just user friendly, it saves money too. There is no point in developing intelligent monitoring systems if the benefits do not outweigh the costs. It is important to keep the costs low. Smart data management and streamlined workflows deliver top tier monitoring without a hefty price tag. Intelligent data lifecycle management reduces storage costs by 65%. Stream processing optimization delivers 40% higher efficiency. Right sizing and workload elimination achieve 30% reduce resource savings. This makes the monitoring both comprehensive and cost efficient. This platform doesn't just save costs, it's built to grow. The platform processes massive telemetry volumes with millisecond alerting latency. Horizontal scaling supports future growth, while predictive scaling anticipates demand. Reliability is validated through load testing, chaos engineering, and meta monitoring of the platform itself. Sophisticated caching and benchmarking maintain exceptional performance under stress. So, how does this get rolled out? Let's talk best practices. Key success factors include infrastructure as code for repeatable, auditable deployments, comprehensive integration testing for realistic validation, team training and knowledge transfer for operational independence, incremental adoption to deliver quick wins and build confidence. Start small, see quick wins, and scale up as confidence grows. This platform is not standing still. Let's look at what's next. Planned enhancements include advanced AI models with a deeper understanding and exploring smarter AI for trickier predictions to keep the number of false positives insignificant. Native cloud integration with service meshes, serverless, and eBPF observed. Edge computing support for constrained environments. Immersive visualization, intuitive navigation for complex systems. The future of monitoring is about staying ahead, and this platform is leading the charge. Let's wrap up with what this means for everyone. This monitoring platform demonstrates how modern platform engineering can transform operations. This platform transforms monitoring into something smart, scalable, and developer friendly. Treating infrastructure as a product enables continuous improvement, scalability, and reliability. It's more than tech, it's a way to build infrastructure that teams love, balancing reliability and innovation. Intelligent automation turns reactive monitoring into predictive, self optimizing infrastructure. Consider how this approach can elevate systems and drive progress. Thank you.